Today we're going to practice using permutations. So if you remember from yesterday, permutations are NPR. The fundamental counting rule, which is the blanks when you multiply the numbers together, and combinations, NCR. So we're really going to look at when do you use which one. Remember that permutations, NPR, that's when you are putting in order. So NPR, put in order. NCR is when you're choosing things and the order doesn't matter. The fundamental counting rule is really best if there's like categories of things. Like if you're trying to create an order that includes appetizer, entree, and dessert, and there's a certain number of options for each of those categories. So in number 1A, we are arranging all of the letters of the word rock. How many letters are in the word rock? 4 letters. So for part A, we are arranging all 4 letters. You could either do the blanks. So 4 letters are, you could have any of those 4 letters for the first letter. And then after you use a letter, you'd have 3 letters left that could possibly be the second one, and then 2, and then 1. This is the same as 4 factorial. It also happens to be the same as we have 4 letters and we are putting all 4 of them in order. So 4 factorial is really the same as 4p4. In part B, we are arranging 2 of the 4 letters. So we have 4 letters and we are putting 2 of them in order, 4p2. Now, once again, I am not going to actually calculate each of these. I'm just going to set it up, assuming that you all know how to enter 4p2 into your calculator. If you do not know how to enter 4p2 into your calculator during work time, please make sure you ask me and I will show you. Number 2, the letters of the word family. How many letters are in the word family? 6 letters. If we are arranging all of them, we can do 6 factorial. If we're arranging 2 of them, we have 6 letters. We are arranging or putting in order 2 of them. You might want to make yourself a little note here. If you are arranging all, you do the total number factorial. If you're arranging some, you do the total number p and then however many of those you are arranging. Number 3, how many ways can you pick out an outfit if you have 5 pairs of shoes, 2 pairs of pants, and 3 shirts? Do you see the categories here? So here's a blank for shoes, blank for pants, blank for shirts. We have 5 pairs of shoes, 2 pairs of pants, and 3 shirts. Personally, I feel like this person did not plan their wardrobe very well, because really 5 pairs of shoes and only 2 pairs of pants and 3 shirts? What? This is also assuming that all of your shoes coordinate with all of your pants, coordinate with all of your shirts. So apparently this person's going to wear stilettos with sweatpants one day. You know, no big deal. Number 5. 11 students are competing in an art contest. In how many different ways can the students finish first, second, and third? Notice they're giving you specifically first, second, and third place. They're telling you that the order that they finish is important, because Lowry finishing first in an art contest would be different than Reagan finishing first in an art contest. Okay? So we have 11 students total. We want to put 3 of those 11 students in order, first, second, third. Now, here's the thing about permutations and the fundamental counting principle. They're honestly the same thing. So this is the same as first place, second place, third place. There are 11 students who could potentially win first place. Once somebody wins first place, there are 10 students left who could potentially win second place. and there are 9 students left who could potentially win 3rd place. So 11p3 is honestly the same as 11 times 10 times 9. But if you're doing something like 20p7, you don't really want to have to punch in 7 numbers into your calculator. So 11p3 allows you to get that answer punching fewer things into your calculator. Number 6. I'm really tempted just to throw number 6 out because it's kind of a poorly worded question. What this question is trying to get across is there are 64 golfers that participate in a golf tournament. We're going to play in groups of 4. How many ways can we get a group of 4? How many different groups of 4 are possible? So this is, well, it's not just 64 divided by 4 because we want to think about how many ways could we group people. So in one way, this row's a group, this row's a group. In another way, these 4 are a group and these 4 are a group. So how many different ways are there to group 64 people into groups of 4? Now, it doesn't matter if we say Lowry then Matt or Matt then Lowry. They're both going to be in that first group. So here the order doesn't matter. So we have 64 people. We are choosing 4 of them. How many ways are there to choose 4 people out of 64 to be on a group? In a group. Number 7 is like a very real world problem for me. So here's number 7. You want to purchase vegetable dip for a party. The grocery store sells 7 different flavors of vegetable dip. You have enough money to purchase 2 flavors. I told you this is very realistic to my life. 7 dips, I want all 7. I can only afford 2. How many combinations of 2 flavors of vegetable dip are possible? Now, this problem actually gives you a huge hint by saying how many combinations. If you see the word combinations, you're using C, period. So we have 7 possible dips. We are going to choose 2 of them. If I choose ranch and onion, that's the same as choosing onion and ranch. If we used permutations, ranch, onion, onion, ranch would be considered 2 different options. Number 8. How many different ways can 8 computer operators be seated in a row? Does it sound like order matters on this one? Yes. And are we arranging some of them or all of them? All of them. Anytime you're arranging all of something, do that total number factorial. You're doing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that will tell you how many ways you can arrange all of them. Okay, I would like you to try number 9 and number 10 on your own because I think that you can do them on your own now. So number 9, what I want you to notice about number 9 is the categories. Do you see how there's the computer category, the printer category, the monitor category? And then they're asking how many ways can you use all 3 of those categories at once? How many ways can you design a computer system if you have 5 options for the computer, 4 options for the printer, and 2 options for the monitor? This is the fundamental counting rule or fundamental counting principle. 5 times 2 times 4, which would be 40. So there's 40 possible computer systems that you could design. Number 10, there are 15 people running in a cross-country race. How many ways can they finish the race? It doesn't say how many ways can they get first, second, and third. So you're not doing 15p3, you're doing 15p15. Or think of it like number 8. You're arranging all 15 of them, so it's 15 factorial. And hint, 15 factorial is the same as 15p15. Whichever is easier for you to plug into your calculator, go for it. Okay, number 11 and 12 are a really great way for us to think about when do we use P and when do we use C? When do we use permutations? When do we use combinations? To complete an exam, you must answer 8 questions from a list of 10 questions. In how many ways can you complete the exam? Do you think it matters which order you answer those 8 questions? No, what matters is take 8 questions and answer them. Bless you. So we have 10 questions. We are going to choose 8 of them to complete. Okay, keyword. If you can use the word choose with order not mattering, then you're using C. Number 12, 10 students are auditioning for 3 different roles in a play. In how many ways can the 3 roles be filled? So, question for you. Say we're doing a play called Rapunzel. Lowry being cast as Rapunzel, would that be different from Paige being cast as Rapunzel? Personally, I think I'd kind of like to see the version with Lowry as Rapunzel, but it would definitely be different. So you're looking at order. If there's 3 roles that have to be filled, whether it's filled student A, student B, student C, or student B, student A, student C, the order that you fill those roles does matter. So this is where we use P, 10P3. 10P3 happens to be the same as there are 10 people possible to fill the first role. There are 9 people possible to fill the second role. There are 8 people possible to fill the third role. Permutations and the fundamental counting principle can be the same thing. But if it's easier to type in 10P3 into your calculator, do it that way. If it's easier to do 10 times 9 times 8, do it that way. We are going to select a committee of 5 people from a class that has 28 students total and 18 males and 10 females. How many ways are there to select 5 people for the committee if we select only from male students? Now, it doesn't say anything about president, vice president, secretary. It's just 5 students are going to be on a committee. So the order that we select them doesn't matter. That means we're going to use C. So out of 18 male students, we are going to choose 5 of them to be on the committee. How many ways can you choose 5 out of 18? 18C5. If we choose 5 from the females in this class, it would be 10, because we have 10 females in this class. We are choosing 5 of them. Now for the interesting part. 3 male students and 2 female students. So for the male students, we have 18 males. We are choosing 2 of them. You're right. We're choosing 3 of them. For the females, we have 10 females. We are choosing 2 of them. When we're counting, if you see the word and means multiply. If it said or, we would add. But if we see and, it means multiply. So this is like combining combinations and the fundamental counting principle. This blank is for male students. This blank is for female students. Multiply them together. So E, I'll bet you can do E on your own now. Why don't you give E a try on your own? Okay, so if you want to put this in your calculator, put parentheses in there. For this one, 3 outfielders out of 5, that'd be 5C3. 4 infielders out of 7. This right here should be a 4. There you go.